All right. Hello again. This is the Autodesk Fusion Generative for Manufacturing webinar. My name is Mike Fiedler, and with me is Apollo Vandenberg. We are enterprise simulation specialists here at Autodesk, and we're going to walk you through the presentation today. So let's go ahead and get started with it. The agenda for today, we're going to talk about what generative design for manufacturing is. We will also cover a brief demo of the product so that you can view what the workflow is. And we will cover what your next steps would be after watching this presentation. If you are interested and it looks like it will meet your needs, or you want to explore it more, we'll talk about that. And then we will have time for Q&A, at which point Apollo will have the program open. So we can do a couple things there with the program open. The file that will be open is the model that will be demoed. So if you have any specific questions on that file, or if during the demo there is anything that you see that maybe goes by a little bit quickly and you say, I want a little bit more detail on that, we can go back to that. Or if there is something within the program that maybe we didn't highlight and you know that it exists, or you want to know if it exists, certainly we can show that as well. So at the point of Q&A, I would certainly encourage you to take advantage of that if you need some more time with us showing the software, or again, if there are any questions that you have that don't get addressed in the beginning portion of this presentation. Okay, so let me start with this. Why would we care about generative design? Hopefully everybody cares at least to some extent. You cared enough to join the presentation, right? So you have a little bit, at least, of understanding about what the program potentially will do. But I always want to start with, why do we care? Why else would you invest your time? Well, first of all, we're going to give you a couple of examples here about, real world uses of the software. So on the left-hand side here, we have the General Motors seatbelt bracket, right? And this just highlights one aspect of generative design, where they were able to take 8 different parts and utilize the software to produce a single equivalent output part, and that can optimize the mass, which in turn improves the efficiency of the vehicle, and it reduces supply chain costs associated with each of those unique parts that may have had to have unique suppliers and costs associated with it. And then on the right-hand side there, you see a wheelchair from Disrupt Disability, and they're using generative design to make wheelchairs and allow people to customize them as they might like. So it allows it to be lightweight, right? So the chair takes the least amount of effort to move around. And then it also makes the parts be able to be interchangeable so that each person can make them unique to their own personal dimensions as well as preferences, right? So there are many, many more examples out there of companies utilizing the software. So right now, various companies are producing parts with the product and quite successfully. So just 2 examples here to let you know. Let's highlight what is Autodesk Generative Design. Well, it's a design exploration technology. And in short, it simultaneously generates multiple CAD-ready solutions based on real-world manufacturing constraints and product performance requirements. I always point over to the illustration of the chairs on the right-hand side here. So this is an idea of, in a way, what generative design is going to do for you. In short, output many options, and then you can choose based on those different outputs, some of those that you might want to explore further. And by exploring further, when it comes to the output, then you're going to take a look at what are the mass of these different parts, perhaps what's the stress on these different parts, what are the different materials, the different manufacturing methods, and then you can choose the one or a couple of them that best suit your needs and then explore those further. All right. So how does generative design help your product development process? Why might you want to employ it? If you take a look at the traditional process, traditional product development process, you have a person or a couple people perhaps within your company that are assigned the task of coming up with a few different concepts, right? And they only have so much time that they can utilize or spend on coming up with these different concepts. And they might base that on, their experience or some things that they've seen. And then of course we take these concepts and we need to validate one of these concepts and make sure that it's manufacturable, right? Make sure that the stresses are within reason, that the displacements are within reason, things like that. And we kind of go back and forth, and we might have to evaluate different concepts. We might have a very good concept, but find out that the stresses are too high. So we have to go back, elaborate on the concept, maybe make it thicker, etc. And ultimately, we can finally produce one of these concepts, right? So we have a motorcycle swing arm here that we might come up with in a rather traditional development process. And we have a fairly long iteration phase, and we have a certain amount of time that is spent on going from actual design to production. When we contrast that with generative design, we say that it helps the development process. And the reason why is because you get multiple validated manufacturable options. The manufacturing process is one of the inputs to the program. So you can tell it, I want to explore, maybe this is a 3D printed, or I want to explore this as using a 5-axis mill, for instance. So there's multiple options that you can put there. One of the other inputs to the program is the material. So you're going to define, I have a material I can utilize, or I have these 3 different materials, 5 different materials that I can utilize. You're going to input what the loads are. So in that chair example, it knows, this needs to be able to withstand a load of, say, a 250-pound person, if that's your upper limit for that design. All right, so you put the loads in. You also apply the constraints. So once you define these inputs, then what the program does is it comes back with these multiple outputs for you that are validated manufacturable output options. So then you can take the one that best suits your needs and in the design to make process, produce the part, right? So this shortens up your iteration phase, shortens up your design to production phase. And you can see what that swing arm might look like as it comes out of generative design there on the right-hand side. Okay. All right. And then just to overlay that with the classic production process, then of course, hopefully what we have in the outcome here is a relatively large productivity increase. Besides the outcomes or the additional benefits, of hopefully a lighter part, maybe a unique design is also of interest. So something that's aesthetically pleasing. Let's also contrast this with topology optimization. So you might be familiar or heard of topology optimization and wondering how generative design is different than topology optimization. Let's use an analogy of transportation, right? So if we have a certain amount of cargo that we're going to ship from point A to point B, right? That's equivalent to perhaps our current part or our current assembly. What topology optimization does is it removes material, right? So it looks at your constraint, it looks at your load, and it figures out where's the least stressed regions of my part, and I'm going to make it lighter, or in terms of the transportation analogy, I'm going to make it faster. So for instance, we can get from point A to point B. If we take a shortcut through the Panama Canal, and we're going to go 60% faster, right? So that's what topology optimization does for you. It removes material, makes your part lighter. So it's examining it based on your current material, your current loads and constraints. To contrast that with generative design, it will also do that, right? So it will find you a lighter design, but at the same time, in terms of the transportation, it's also going to examine a truck route, it's going to examine a train route, it's going to examine a plane route. Or in terms of generative design, what about these different manufacturing methods? Right? Can we use a 2.5 axis, 5 axis? Can it be a die cast part? So we have the different manufacturing methods, plus the different materials as well. and therefore you're going to get many more outcomes. And of course, if you look at the graph there in the upper right-hand side, there are trade-offs, right? There's different costs associated with it. In the terms of transportation, there's different security associated with that. Speeds, right? How much cargo it can carry. So similarly, in generative design, you're going to have different mass, you're going to have different displacement, different stresses, different materials and manufacturing methods. So we're going to plot all those out, and then you can look at these different results and determine, what is the appropriate trade-off for me, and what is the best option or best options, and perhaps even explore those further, right? Okay, so when would you utilize generative design? Apollo and I talked about this as we were generating this presentation and trying to come up with, at what point am I going to use it? What is my application? Well, we see three different overarching or major buckets that it might fall into, and one is when you're completely coming up with a new product, right? You might not have necessarily a preconceived notion of what this final part looks like. You know that it needs to withstand a certain load. You have an idea that you're going to use some sort of material for it. Maybe a couple different materials possibly can be utilized for it. You know what your constraints are. So you could utilize generative design to help you narrow that down. So from the outcome of that, you could see how those different materials behave. You could see how much material it's going to utilize. But you can explore more design alternatives, right? Because generative design is going to give you many outcomes. And then based on what you see from that, right, you can create your final design for production. So it can help in the ideation phase for sure. Another reason that you might utilize it is for part consolidation. So this is similar to that GM seatbelt bracket. You might have something that's currently an assembly of 2 or 3 or 10 different parts, and you can use generative design to consolidate those down into a single part. So that way, potentially you can reduce raw materials. You certainly can reduce the number of parts that you need to perhaps order from different suppliers and maintain inventory of. And then thirdly, and not to be discounted, and this is probably where a lot of people start, I would imagine, that's with part enhancement. So you can take an existing part, apply your loads, apply your constraints, and you can run it through generative design and see what it comes up with as an output. So it can lightweight that part for you. You can explore different materials with it. And perhaps come up with a new and different design based on that original geometry. So you can certainly input existing geometry as a starting point to the program. Don't have to, but it's certainly an option. Okay, so let's talk a little bit about the outcomes of it. So I've been talking about the input, right? We have loads, we have constraints, we have material, we have different manufacturing methods, and it's going to output a bunch of results for you. So we know that the ultimate goal for any engineering activity is to find that right balance between the performance of it and what the cost is to produce it, right? We are also well aware that engineers are limited in the time and energy that they can spend on any design problem, right? Both of us have, a foot within product support, and I don't talk to very many engineers who say, well, I'm just exploring this because I have a whole bunch of time on my hands and not much going on right now, right? People are usually trying to get through something that is due, last week, or it's due in the very near future. So time is limited. And I think that's one of the great things of generative design is it helps in being able to produce all these different outputs for you. Certainly many more than I could come up with on my own, probably within the time that I'm giving to be able to produce it. All right, so we're going to talk a little bit about the price performance curve, and this price performance curve, we're gonna lay out, what is the cost to produce versus what is the performance of this particular part that I might get, or one of these different outcomes that I get from generative design. So again, if we use a transportation analogy in terms of cars or vehicles here, at the one end of the spectrum, cost to produce along the horizontal axis, performance along the vertical axis, right? there are many different cars out there, right? So at the one end of the spectrum, we have low cost plus perhaps low performance cars. And then you have your mid-range vehicle, and then we have a high cost, high performance vehicle, right? All these can perform the same basic function. You get in it, you start that car, and you're gonna be able to go from home and ultimately get to work, right? But the experience with these cars are all different. The longevity or reliability of these cars are potentially all different. I'm not, not saying anything in particular about any particular vehicle here, just trying to make an analogy, right? And so we have a lot of different outputs or a lot of different vehicles that we can choose from. And that's kind of the thing about it, right? We all get to personally choose. None of us all are probably within the same spectrum. None of us are, all driving the exact same car at the one end of the spectrum or right in the middle necessarily. We give options to our consumers based on what we want to offer and what we think the market is going to want, okay? So let's go into a part example here. So this is the GE Aerospace bracket. You may have seen this from some other discussions. This is something that GE put forth a few years ago. And what they did was they asked the user community to come up with a new design for this. So they basically said like, hey, here's our existing part. These are what the constraints are. And it was constrained in the 4 holes. And then in the 2 lugs here, they said these are what our loads are. We have this vertical load, we have this horizontal load, we have these particular moments. Let's see what you can come up with. And basically the user community delivered. So the user community came up with a whole bunch of different parts, and so they met the challenge. But the point is that it took a lot of different people, and each one of those people spending anywhere from what, I don't know, an hour to several hours to come up with these designs. So if you take all those hours multiplied by all those different people to come up with these different ideas, it's a lot of time invested, right? So this is where we see generative design being able to help. It can come up with all these different iterations for you, and you being a single person, you're starting with, this is my existing design, here are my constraints, here are my loads, go ahead, generative design, give me these outcomes, and then let me explore these different outcomes and see what works best, what is best for us in terms of cost to produce, what's best in terms for us as far as performance, right? And of course, those two things are gonna, be individual based on your specific requirements, what your company is looking to do with that part, right? All right. So when we talk about outcomes, again, Autodesk Generative Design is going to enable the rapid creation and exploration of your design options so that you can determine what those trade-offs are along that price performance curve. So if we look at the image to the right-hand side there, this graph, this is one of the outputs that you might see within generative design. You can certainly change what you want to plot here. In this particular case, we're plotting the estimated manufacturing cost on the vertical axis versus the mass, and these are all our different outcomes. So you can see that what we're looking at with the different colors are the different manufacturing methods, also something that you can configure within the output. So we have 2-axis cutting output, we have 2.5-axis milling, we have 3-axis milling, 5-axis additive results here, we have die cast results here, and then the unrestricted results. So again, you can choose from multiple manufacturing methods, and then leveraging a priori, you can input how many units do I think I'm going to manufacture. So you specify that as an input. Maybe we're going to make 1,000 of these parts, right? And then it comes up with a estimated cost as one of the outputs. And then you can drill down. So you could zoom in the corner here, maybe you say, within this $200 to $400 range, this is where I want to be, and this is the mass that I'm willing to take. So then you can zoom in and explore just those outputs that are within that region. Or still maybe you're expecting something along the 200 to 400 range, but a mass of, at this end of the spectrum, maybe 4.5 is acceptable. So you can drill down and see what those look like as well. We'll show you a little bit more on the various types of ways that you can explore the outcomes here shortly. All right.
Yeah, so I'll take it from here and kind of talk through a little bit at a high level of what the workflow is with generative design, and then kind of go into a little recording. So, as Mike mentioned, we have three essentially kind of different categories as to why we might be using it. With this workflow, with this demo, we're kind of taking the assumption of maybe that part enhancement category. So, we have existing CAD that we want to try to optimize, that we want to try to maybe test new manufacturing methods, maybe want to test new materials to see if we can save money or save waste but by looking at them. So with that initial CAD, we'll actually project out specific geometry. That geometry will be used to either assign a load and be a region that we want to keep. So like a preserve region to say, this is where things are going to be mounted or bolted, or where it's going to interface with another piece of geometry, or it's going to be an avoidance region, an area that we want to say, we don't want any geometry to be built here because this suspension A-arm actually needs to rotate and we have a frame member there and we can't collide with that frame member. So once we have those projected geometries, we'll go ahead and define those, as well as any loads, any constraints, what materials we want to test. Additionally, as Mike mentioned, the manufacturing methods, which manufacturing methods we want to test against, and then we'll go ahead and generate those results. And then lastly, kind of exploring all of the results from, all the combinations of those materials and manufacturing methods that we get out. So, just to highlight a little bit here, when we talk about manufacturing methods, we're always adding new manufacturing methods. I think last year, we only had maybe 2 manufacturing methods, in the product. And, over the last year, we kind of almost every quarter have been releasing one. So we have to look at additive die casting, 3 and 5 axis, 2.5 axis, and 2 axis cutting. But there are more, in the works, and there are more that we're always trying to incorporate as we move forward. So, here we have, the suspension A-arm, kind of taking it out within the Fusion design space. We can switch to the generative space where we can then make model-specific edits that won't track back to the design space. And here being just that we want to project out, those mounting locations. So where it mounts to the frame, where it mounts to the wheel, where it mounts to maybe the steering arm. And then we're going to also project out a couple of avoidance regions. So, we know that we have to be able to allow the suspension to rotate about the frame. And so these can be crude shapes. They can be more specific if you'd like, as to what they represent. But once we have those model edits, then we can come back into Fusion and start making assignments. So first one's being preserves. So these are areas that we want to keep. They will be included in that final output. They get kind of assigned a green color to kind of indicate that. And then everything else here is an avoidance region. So maybe it's for a bolt hole or tool access to a bolt, just kind of allowing for that clearance hole to be there. Going into loads and constraints, we can have a number of different load cases. So it's not required to have, just one load or just one load case. If you want to have multiple, so in this case, if you want to have one for acceleration, for braking, for turning, the suspension hanging versus fully loaded, you can do so. We can include our objectives. So are we trying to minimize mass or maximize stiffness, what our safety factor is, and then getting into those manufacturing methods. So you can see when I kind of went through this previously, I don't have die casting here, even though it is an option now. But we can set up 3-axis and 5-axis, what angle or what sides or what planes are we dealing with the milling, and then what materials we want to look at. So a lot of times, we might be looking at the existing materials or variations of existing materials, but it doesn't hurt to maybe try something that's completely atypical. If this is a suspension component, we could still try plastic just to see and get an understanding of how and where those loads would get transferred between all these preserved regions. The Fusion will give you a model check to let you know that everything is good, and then we can go ahead and generate. Once you have the results back, we have a number of ways to filter through it, so we can isolate based on manufacturing method to just look at those that were additive or just those that were 5-axis. We can use the filters on the left to kind of group and filter to a specific mass or volume or displacement if we're trying to shoot for a certain target. We can look at these in a table form, sorting by any of the columns. I'd say most commonly though, kind of as Mike was showing in one of the prior slides, the graph is the one that's really useful. So that way we can kind of plot all of them out. And if there is a range of ones that we are interested in, we can just zoom into that graph. And then, from there, you can kind of see the colors are dictating materials. So, maybe we want to look at this one that's aluminum versus the one in orange, which is magnesium, compare them side by side, see where and how things are different, between those two different materials. We can look at the stress concentrations to see how the product, each one is performing from a stress concentration perspective. We can then bring back, if we wanted to see as well, the design space. But as well, we also have the details on the right. So as you select, left versus right, we'll let you know that this was a 5-axis, what the volume is, what the mass is, what the factor of safety is. Once we have one that we like, we can actually then go through and export this back to Fusion and have a fully featured solid geometry, fully editable featured geometry in Fusion. So at that point, if you wanted to take further action into Fusion simulation to doing additional testing and validation, or if you wanted to take this into CAM to start setting up your workspace for how you might approach the cutting strategy, you can do so. You can even make geometry edits, from there for work holding features and things like that. So, we talk a lot about brackets. And Fusion or generative design isn't just around brackets. There are a lot of different industries that can leverage, the ideation and kind of consolidation that comes with generative design. You can kind of see things from like the top left of, headphones to even something industrial design like the light bulb that's down in the bottom right. So there are a number of different ways that you can put this to use. It's just a matter of kind of designing or defining, what regions we're trying to keep and what we're trying to, avoid or kind of keep geometry out of. So it's a really useful tool for kind of getting some of those concepts out there. And if you guys are interested in learning more, one thing to kind of highlight, until the end of the calendar year, there is a free all solves or all simulations for generative design are currently free. So if you do have access to generative design, you have the ability to get into the product and start testing and start learning with it. I will kind of comment two things. At the end of the webinar, as we close out, or right before we open up for questions, there will be a quick survey. One of those questions is if you'd like us to reach out to you, and talk further around generative design. If you say yes to that, feel free to, and we'll kind of connect with you guys to see, maybe what your interest in generative design is and how we might be able to better help. And maybe if it's before the end of the year, how you might be able to leverage some of these, current free tokens and free credits. So with that, I'll go ahead and open it up. If you have any questions, feel free to type them into the chat or into the questions panel that might be hidden off to the right-hand side of your screen. Or if you'd like to talk out loud, feel free to raise your hand and we can unmute you so that you can ask it to the group. So we do have one question coming in, asking just to kind of show a little bit more on some of the manufacturing options there. So I'll switch presenting to myself here real quick, and I'll actually bring up Fusion so that you can kind of see some of those details. So yeah, right at the top, under manufacturing, we have a number of different manufacturing options. So we actually now as well have 2-axis cutting. If you're looking at maybe some sheet. Was there a specific question that you had around those manufacturing options? No? Okay. Anybody else? Any other questions around generative design, its capabilities, how you might be interested in using it? Okay. Well, if there are no other questions at this time, Mike and I are happy to stick around and chat as needed. But if there are no other questions, we can go ahead and call this done. And yeah, like I mentioned at the end of the webinar, as we close out, feel free to answer the two quick questions in the survey if you'd like to have us reach out to you for more information. All right. Well, I appreciate everybody's time.